Good morning. I am Siglos and I am grouped with Carmelo John Ilag and Christian Paul Marco, and our program is about the chi-square goodness of fit test using assembly language via DOSBOX. So what is the chi-square test? Chi-square test goodness of fit is one of many types of statistical tests for many distributions of data. Our main objective is to calculate for the chi-square value from the desired observed value in our text file. So basically the program computes for the chi-square value based on a text file. So we will be using a file handling operation to get the text file, and it will be compared to the code. Next, we aim to also conclude the decision on whether we should accept or reject the hypothesis. When the computed value for the chi-square is lower than the fail to reject region or FTTR, the program should accept or choose the HO, which is the null hypothesis. Otherwise, H1 should be picked by the program.
For the scope and the limitations of our program, the program requires the text file to be in a specific format. The first line should be the population value, and the total observed value should also be divisible by the number of the observed values.
Good day, my name is Carmelo Ilag, and today I will be talking about our program about chi-squared goodness of fit test. So before I show you our program, let's start with how the goodness of fit works. So for the goodness of fit test, the formula for the chi-squared goodness of fit test is chi-squared equals the summation of O minus E squared all over E. So where the O variable is the observed or obtained frequency, and for the E is the expected frequency. So let's manually solve a goodness of fit problem first. So here's a sample problem. A die is tossed 180 times with the following results. So these are the results. So we are required to know or solve it if the die are balanced. We need to use a 0.01 level of significance. So for the solution, here is the table of the observed frequency. So for the O sub f, these are the observed frequency which is given in the problem. Here it is. And for the O sub e, this is the expected result. So how did we came up with the value of 30? So for the calculation of O sub e, the expected value, we get the average of the frequency of each phase of the die. So for O sub e, we added up 28 plus 36 plus 36 plus 30 plus 27 plus 23 all over 6. So the result is 30. So for the value of k is the number of entries or the observed values. So here it is. It's 1, 2, 3, 4, 5, and 6. So for the computation of the degree of freedom, v, variable v, it is calculated by k minus 1. So 6 minus 1 equals 5. So the level of significance that we need to use is 0.01. So if we find the chi-squared value of 0.01 significance and with the degree of freedom 5, the result is 15.09. So for the decisions, H sub O our null hypothesis, the result will be the die is balanced. While for the alternative hypothesis, the die is biased. So putting the values onto the formula O sub e squared over e, this is the solution. It will came up with a result of 4.47. So for the result, 4.47 is less than 15.09. So it is not greater than the 15.09 chi-squared value that we have calculated earlier. So it didn't reach the reject region. So for the decision, FTRR means it has failed to reject the region. So the die is balanced. So the null hypothesis is accepted. So for our program, assembly language program, we have simulated the given problem that we just solved manually. This is the given. Well, our program accepts the values through Notepad, so we just need to put the values in here. Then the program will read it from the text file. So for this, 06 is the value k, or the number of entries. Then the observed frequencies are entered per line. After that, when we run the program, this is the sample output. So this is the first screen. It will show the observed values, total observed, 180, 28, 36, 36. And it will compute for the expected value also. The formula for the chi-squared goodness of fit test is also shown here. And the solution. When after clicking any button, it will go to the next screen, which will show the result of the goodness of fit test. So here is the graph of our chi-squared test. So as we can see, it has the same result from the manual computation that we've done earlier. So the decision here, it accepted the null hypothesis. Same with the program, it accepted the null hypothesis, and it shows a graph of the chi-squared. So for the limitation of our our program, there are two. So the first one is some fractional part of the values are not that precise. So some values are not exactly with the same with the manual solution, and the sum of the entries should be divisible by the size. So preferably the entries should be whole numbers and should not have decimal places.
For our conclusion, upon executing the .exe file, the observed values are obtained from the data.txt file. The program will then get the total observed value by adding all the values contained on the data.txt file. The first line from the text file is the number of population. Meanwhile, the next line will be the observed value. A dash is entered in the end text file to act as an end of file buffer. When the computed value for the chi-square is lower than the failed to reject region, the program should accept or choose the H0 Otherwise, each one should be picked by the program.